I have an equation AB plus CD. See, it's not an equation. I can call it as a function. Call it as a function because if I am going to give inputs, if I am going to give inputs to the system, like how many variables are there? 4 variables, A, B, C, D. If I am going to have 4 variables, each and every variable having Boolean values 0, 0, 0, 0, 0, 1. I think 4 bits are there. You are going to get 16 patterns. You are going to get 16 patterns, and for each and every thing, you can able to generate multiple functions like function 1, function 2, function 3. What are the function 1 defines? All may be zeros. So like that you may generate multiple functions. Among those, one kind of function I am assuming it as AB plus CD. AB plus CD, right? Assume that AB plus CD is my outcome, right? How we are going to design it with help of these basic gates. How we are going to get AB? AB means what? AND gate. So if you are going to give A as input and B as input, you are going to get AB as output. And if you are going to give CD as inputs, here you are going to get CD as output, and then they are going to perform OR operation, right? For OR operation, you need to use OR gate. So your result will be AB or CD. AB or CD. Okay, guys. For example, let me take one more function. Uh, X plus Y into X plus Z. For this, can we construct the circuit? Yes. Try to observe. What is X as one input, Y as input? OR means what? OR gate I need to use. Next, X plus Z. I need to use OR gate, one more OR gate. And for this, they are going to perform. So you are going to get here as X plus Y. You are going to get as X plus Z. For this, you are going to perform AND operation. So your result will be X plus Y and X plus Z. I hope you understood, right? This is what we are doing with the help of basic gates, what we have seen so far, right? Here, guys, try to think when somebody is trying to design this circuit, they are using two OR gates, and one AND gate, right? Is there any way can we reduce this circuit so that cost of the circuit will be reduced and time taken to produce the result also will be reduced, right? So what is that? Can you answer? Yes. See here, if you are able to solve this equation, can you do it or not, right? So if you are going to perform like multiplication, right? So instead of saying like x into, if you are going to do that, x into x plus x into z, y into x, y into z, right? What is x into x? You are going to get x. So if you are unable to understand, x into x is x, which is idempotent rule that I will take in the next slide itself. X into x is x, xz, yx, yz. Okay, fine, guys. If you observe here, you can take out the common thing for x into 1 plus z. See, from these three you can take out the common as x, right? Then 1 plus z plus y plus yz. See, from these three I have taken one thing as common, right? 1 plus anything is what? 1 only. 1 plus anything is 1. So this entire thing I can able to make it as 1. X into 1 is x, x plus yz, right? Now this is the alternative equation for this function. Right? Now can I able to construct the circuit for this one? Yes. What is yz? Y as input, z as input. I think it is AND operation. So your result will be yz. For this result, we are going to perform OR operation. So you will get like this x. So your result will be x plus yz. See guys, if you are going to give the inputs in any manner, in any order, if you are going to give the inputs 0, 1, 1, 0, sorry, as I am giving here as 0, this x also should be 0, right? So whatever result that you are going to produce by this circuit, the same result will be produced by this circuit also. See, x is 0, y is 1, z is 0, right? What is x plus y? Meaning that OR gate. On OR gate, when one input is low, another input is high, output will be high. So here you are going to get output as 1. Here what? When both inputs are low, your result will be low. What is, so as 1 you got, that 1 will be given here and 0 will becomes here. 1 with AND gate, 1 and 0. So you are going to get the result as 0. So for the inputs x as 0, y as 1, z as 0, your result will be 0. The same circuit, take out this simplified equation. X will be as it is comes here 0. What is yz? One is 0, another one is 1. Then your result will be 0. So that same 0 will becomes here 0 or with 0. You are going to get 0, right? So for this circuit also result will be 0. So, but the thing is here, the same outcome you got for the same inputs, but here cost is more and number of levels are more. Number of uh, levels are equal as of now, but if you take large number of very large equation, then number of levels are also going to be increased. So that's the reason whenever you got any kind of a function, you try to simplify that function first, right? So to simplify that function, first you have to know various kind of algebraic function properties. Various kind of algebraic properties, right? First, what are the things that we are trying to discuss? All those will comes under a concept called Boolean algebra. It's not relational algebra. Relational algebra is comes under DBMS. Boolean algebra comes under DLD. Okay, Boolean algebra means something like whatever the function that you are trying to get, you need to analyze that function. You need to analyze the function, and you have to simplify that function. You have to simplify that function to to like to implement a circuit in a simple manner. So Boolean algebra is a kind of a concept which is meant for to analyze and simplifies the circuit diagram. That's it, right? So basic thing in Boolean algebra is the minor parts are, one is Boolean variables. Boolean variables. All these Boolean variables can be available in normal form like variable x or its complemented form. Right? Technically, we could call these as literals also. Right? And we can represent 0, 1 are the Boolean constants. Right? So here in Boolean algebra, the variables are 0 and 1, and we have various kind of Boolean operators are there. One is plus. Plus means I can technically related with a gate called OR gate. Dot is AND operator, Boolean AND operator. We can technically relate with AND gate. So OR gate, AND gate, and this is what I can call it as NOT gate. I can call it as complement operation. Okay. See here, 0 means I can basically call it as false or low. 1 means high, okay, or true. That you can understood easily, right? Fine. So this is like what we have seen so far also, right? So meaning that when you would like to view represent AND gate in terms of any kind of expression, we can use dot operator. OR gate in terms of expression we will use plus operator. Complement in terms of expression we are going to use symbol like minus symbol, or sometimes you may observe some kind of cap like this, apostrophes, right? Meaning that if I say that a variable x whose complement is x bar, or I can write it as x power 1, like this I can able to